Hello, Henrico Mathematicians. Miss McMillen here, and I'm so excited that you decided to join me in my home classroom. Today, we're going to explore pattern tables. Specifically, we're going to explore how to identify the rule or relationship in a pattern table, use that rule and relationship to describe what's occurring in that pattern table, create our own tables, and we'll even get to extend or expand upon a pattern table. As mathematicians, when we work with and create pattern tables, like the ones up here, you'll notice that they're always organized with rows and columns, and that it is of utmost importance that first we identify the relationship between the numbers in our pattern table. This relationship between numbers will allow us to identify a pattern rule. By identifying a pattern rule, it'll allow us to find missing pieces that are in our pattern tables, or it'll allow us to continue to expand our pattern tables. When identifying a pattern rule as fourth grade mathematicians, we're going to use three different operations. You'll see the operations of addition, subtraction, and multiplication present in your pattern rules. Today, we're going to have a few pattern tables to create together, and we're going to have a few pattern tables that are already created for us, like some of these. We'll just need to identify the pattern rule, and then we'll be able to complete the table. Hey, Saber, come on in. I'm so excited you want to join us for math today. You're going to be a huge help as we figure out our patterns in a table. This is my dog, Saber. He's a husky. We adopted him from the pound about 11 years ago. Now, like most huskies and most dogs, Saber has 4 legs. So let's create a table where we figure out how many dog legs we would have as we continue to adopt dogs. So let's think about this. Saber is one husky. He has 4 legs. Let's add that to our table. Now, let's say tomorrow I go and I adopt another dog, another husky. So I had my original 4 legs in our house, and now I'm adopting another dog. So I'm going to have 8 total legs. Now, I decide I want even more puppy dogs. So, if one husky had 4 legs, 2 huskies have 8 legs, let's add another one, 8, 9, 10, 11, 12. Okay, 3 huskies would put 12 legs in our house, 4, 12, 13, 14, 15, 16. 4 huskies would give us 16 legs. Now, as mathematicians, we could continue going all the way down this table and just adding 4 legs down. But we can also identify the pattern rule or the relationship between our number of huskies and the total number of legs that will allow us to extend or expand our table no matter how many huskies we have. So let's think about this. If we have 1 husky, there are 4 legs. So we know our number is increasing. We can either use the operation of addition or multiplication, which show an increase. Well, 1 to 4 would give us a plus 3, but 2 plus 3 is only 5, so I don't think I'm going to use the operation of addition. Let's think about how the relationship between 1 and 4 is with multiplication. Our identity property tells us that 1 times 4 gives us a product of 4. 2 times 4, oh, that gives me a product of 8. This could work. So 1 times 4 is 4. 2 multiplied by 4 is 8. 3 times 4 gives us a product of 12. Notice that as a mathematician, I'm going to continue to apply my pattern rule to my entire table. I'm never just going to stop after my first 1 or 2 because I want to make sure it works. 4 times 4 is 16. So we know my pattern rule is to multiply by 4. So let's say I get 10 huskies in my house. How many legs would I have? I can apply my pattern rule. 10 times 4 would give me a product of 40. Or let's say I only want 8. I can continue to apply that pattern rule. So 8 times 4 would give us a product of 32 husky legs. That's a lot of dog legs in our house. I'm so glad we used our pattern rule to identify that. Thanks, Saber, so much for your help today. You are such a wonderful math dog. In real life, as mathematicians, we can use tables and identify the pattern rule in the table to help us solve more complex problems. A lot of you all might have been introduced to pattern tables in 3rd grade. Thumbs up if you've seen this before. Awesome, Henrico. Well, some of your 3rd grade teachers might have introduced you to an input-output table. Just like when we were trying to figure out how many different legs we would have based on our number of dogs, we're going to do the same thing when we look at the relationship between the numbers that go in and then the numbers that would come out. And we're going to identify a pattern rule in order for us to continue to expand this table. Lucky for you all, I brought my input-output machine home with me from the classroom. So let's use our input-output machine to build our table together.
I'm hungry for numbers.
So glad you're excited to learn with us, input-output machine. Our first number that we're going to put in is 45. Put in 45. We'll record 45 as our input on our table, and our input-output machine spit out 38. Ooh, this is going to be great, mathematicians. Let's think about this. If 45 went in and 38 came out, that's a smaller number. We're seeing a decrease. My brain's already thinking about how we might use the operation of subtraction when we see a decrease to write this pattern rule. But remember, we never ever identify our pattern rule just based on one number relationship. We need to look at several. So let's put another number in. This time, we're putting 40 in. If 40 goes in, and we'll record that on our pattern table, the input-output machine gives us 33. We're still seeing a decrease in numbers. My brain is still thinking subtraction. I'm already thinking about this relationship. Let's try another one. 38 goes in. Let's see. We know we're going to use the operation of subtraction if it's smaller. And 31 comes out. Record that on the output side of our table. We'll try one more with our machine today since he seems so hungry for numbers.
Yum, 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 yum.
34 goes in. 34. Thank you, input-output machine. Nothing came out. Ooh, as mathematicians, in order to find the missing piece in this table, we have to identify that pattern rule. So, from 45 to 38, we know we saw a decrease there. So I can think about the difference between these two numbers. So 45, back 5 plus 2. 45 minus 7 would give me a difference of 38. Let's see if a subtract 7 rule would work all the way down. Our input-output machine seems to already be agreeing. 40 minus 7 would give us a difference of 33. Okay, 38 minus 7. We're still getting our difference then would be 31. So let's apply this pattern rule. If we're thinking our pattern rule might be subtract 7, 34 minus 7, back 4, and another 3, would give us a difference of 27. Thank you, input-output machine, for building this beautiful table for us. And by identifying the pattern rule, we were able to figure out your missing piece. Sometimes as mathematicians, when we're working to identify a pattern rule to expand or find those missing pieces in a table, our tables are horizontal instead of vertical. That's okay. We can apply that same strategy. We can continue to look at the relationship between the numbers that are going in and what's coming out, or different variables that are affecting each side of our table to identify that pattern rule and expand. So if you look at this table here, this time I have a row of ins, and we're going to put some numbers back into that input-output machine again, and then we have a row of outs. And we'll continue to look at the relationship and how this number changes when it goes in the machine and what comes out in order to expand this table. Are you ready, input-output machine? Okay. This time, I'm putting 5 into our machine. Let's see what kind of number he gives us. So 5 comes in, and 10 comes out. Interesting. Some of you mathematicians may already be trying to guess the pattern rule and telling me to add 5 or to multiply by 2. Remember, we never ever identify a pattern rule until we have several pieces of our table filled out, because it'll change and relationships need to look at the entire table to identify that pattern rule. So let's put another number into that machine. This time, let's put 7 in. If 7 goes in, what is coming out? Thank you. 12 came out. See how important it was not to say multiply by 2 quickly? Because 7 times 2 is 14, so that wouldn't work. Let's keep going. Let's put 10 in. If 10 goes in, let's keep working on this table. 10 goes in. 15 comes out. We'll continue to expand our table. 5 went in, 10 came out, 7 went in, 12 came out, 10 went in, 15 came out. So I know I'm increasing. I know I can't just do multiply by 2 because 7 times 2 is 14. 5 plus what would give me a sum of 10? 5 plus 5 would give me a sum of 10. Let's see if that works. 7 plus 5. 7 plus 5 would give me a sum of 12. Let's see if we're still working. 10 plus 5 would give me a sum of 15. 18 plus 5 would give me a sum of 23. Let's put 18 in and check our work. If 18 goes in, if we want to say our pattern rule is plus 5, we should get 23 out. Great job, mathematicians. So far, our pattern rule holds. 18 went in, 23 came out, giving our pattern rule of plus 5, or to add 5. Okay, input, output. I'm putting 26 in. 26 goes in, 27, 28, 29, 30, 31 should come out if our pattern rule holds true. Let's see. You're not even going to tell us. You just know how brilliant you are. So, when you see a horizontal table, you're still looking at the relationship between what goes in and what goes out. Remember, as mathematicians, we look at our pattern rule all the way across. Great job, input-output machine. Thank you so much for helping us identify our pattern rule so we were able to continue to expand our table. Thank you so much, Henrico 4th graders, for learning alongside me today. Remember, when we're identifying patterns in a table, we must use the relationship between the numbers in our table to identify a pattern rule. This pattern rule will always allow us to expand upon our pattern tables or to find the missing pieces. Good luck and have a wonderful day.